Here we're asked to identify a number as whether or not it's rational or irrational. So remember, our definition of a rational number is something that can be represented by a terminating or repeating decimal. So something like, well, certainly an integer, 5, 37, something that can be represented as a fraction, 5 halves, or terminating or repeating decimal, 3.75, that's terminating decimal, or a repeating decimal, 2.3 with a bar over it. That means the 3 goes on and on and on. An irrational number will have something like pi. Pi is an irrational number because it's actually a decimal value that repeats and goes on forever and ever, and there's no pattern to it, there's no repetition. So that's an irrational number. So anything with a pi would be an irrational number. If you have a square root of something that's not a perfect square, so let's say 13 is not a perfect square, so that would be an irrational number. Oh, and so in contrast, if I had a perfect square inside my square root sign, then that would become a rational number again. So let's go and take a look at some of these problems over here on our left-hand side. If I look at square root of 16, well, 16 is a perfect square, right? And that can be evaluated to 4, so that's rational. 55.90, and with that bar over it, that's just a repeating decimal. Meaning it's 55.9090909090 forever and ever. So that's rational. Here we have 7 pi, and remember I told you anything that has a pi is going to be irrational. Let's see. Next one is negative square root of 17. Well, is 17 a perfect square? 17 is not a perfect square, so it's irrational. And then the last one here is just negative 91.99, and that decimal terminates. So it's rational. Okay, so these are kind of the explanation for what makes a rational and an irrational number. Okay.